Write down the question. Find out the center of mass of a uniform. Find out the center of mass of a uniform. Rod of mass M. Rod of mass M. And length L. And length L is so ikkada ఏంటంటే ఈ టాపిక్ in this topic just this is the one base to the continuation of the topic. So what's that base? Nothing but continuous mass distribution. So what is the continuous mass distribution? So discrete mass distribution and continuous mass distribution. Discrete mass distribution means the particles are at some places. So this is one particle M1 and this is another particle M2 and this is another particle M3. So these are the discrete masses. So M1, M2, M3, M4, like that, the distribution of the particles considered. Whereas continuous mass distribution is nothing but the particles are arranged in a particular order. For example, if you take a rod, so rod is nothing but it made up of with one type of substance. Substance is nothing but group of particles. So the particles are, number of particles are present. We don't know the number of that particular particles. We don't know the number of the particles. How many number of particles are there in that rod? We don't know that. That is nothing but continuous mass distribution. For example, the length of the rod is L. The mass of the rod is M. Here, for the continuous mass distribution, we used to take one physical quantity, and that physical quantity is linear charge density. What is that, ma? Linear charge density is one physical quantity which we considered for the continuous mass distribution if that substance is like length of the rod. So if the rod is nothing but the main dimension is nothing but length. In case of the rod, what is the main dimension, ma? What is the main physical quantity? Length is the physical quantity. The particles are arranged along the length, either x-axis or y-axis or z-axis. So whenever the particles are arranged along the length of the rod, then we used to take one physical quantity, linear, length related with the linear. Wherever the word link up with the length, that topic is based on linear mass density. So here the particles having the mass in a particular region, and that's why here we are taking that linear mass density. Are you getting what I'm saying here? Okay, now in this, linear mass density can be represented with lambda. Lambda is equal to mass per length. Lambda is nothing but what? Mass per length. Okay, so now in this case, simply linear mass density is nothing but, or linear density is nothing but mass per unit length. We simply represent that mass per unit length. So this I am representing that lambda is equal to m by l. If the distribution is along the x-axis, if you want to represent the center of mass of that particular substance with respect to origin, for example, I don't know the center of mass, position of the center of mass here. I need to calculate the position of center of mass along this length of the rod. You treat as this is the origin, starting point, that is the origin. So you consider this is the x-axis, and this is the y-axis, and this is the z-axis. I consider this is the x-axis. Along the x-axis, here the linear distribution of the mass is present. So here to calculate the center of mass for this topic, here I am taking that xcm is equal to integral x into dm by integral dm. Integral x into dm by integral dm. And this is the position of center of mass along the x-axis. So why I consider the xcm here? Why? Because here I consider the substance, I consider the rod along the x-axis. So I consider this formula. If the rod is along y-axis, then you used to take the formula as ycm is equal to integral y into dm by integral dm. If the rod is arranged along the z-axis, zcm, the position of the center of mass with respect to z-axis of this rod is zcm is equal to integral z into dm by integral dm. Okay, so like this we used to take. Here, what is the dm? How come we consider all these things? We can consider by using one problem. By taking one problem, I can say how to solve like these models. Getting? అర్థమైందమ్మా? గుడ్. సో ఇప్పుడు మనం ఒక మోడల్ తీసుకుందామా? మరి ఆ మోడల్ తీసుకుంటే నీకు క్లియర్ గా అర్థమవుతుంది. రైట్. If the linear density of a rod, if a linear density of a rod of length capital L, varies as lambda is equal to a plus bx. Lambda is equal to a plus bx. Lambda is equal to a plus bx. Find the position of its center of mass. Find the position of its center of mass. Okay. So once again, read that numerical yourself. I also reading that numerical. If the linear density of a rod of length is capital L, varies as lambda equal to a plus bx. So here given the equation as linear density lambda is equal to a plus bx. A plus bx. That is the given equation. Okay, so here length is varying. That is in the form of x. How come it is varying? That we are representing here. See, this is the length of the rod. This is a rod having the length is L. Having the length is L. Okay, so now this I am taking along the x-axis. This is the origin. You consider this is the origin, and this is the x-axis. X-axis. Now, from the origin, I consider a small portion. A small portion is considered from the origin. What is the length of this portion? This is varying with the x. X is the length. From the origin, if you go on increasing the distance, the rod length also increases. If the rod length increases, the mass also increases. For example, if you consider up to here, so this much mass only I considered. If I consider up to here, that this much mass I considered. If I consider up to here, this much total length of the rod I considered. It means if you go on increasing the length of the rod from the origin, the mass distribution also gradually increases. The mass also increases. For that purpose, here I considered like this continuous mass distribution wherever the topic it is. For the continuous mass distribution, we considered a small region of length. The small region here I am taking that dx. Why? Because along the x-axis here I considered, so that small region is nothing but dx. If that small portion is dx, and here with that we are taking the concept it as linear density. How come we consider the linear density? As you know very well, lambda is equal to, previously I said to you that mass per length. Mass per length. So this is constant for every concept of ratio between the mass by length. For example, if I consider the length dx, in the small length, what is the amount of mass? Small length. So the small distribution of mass is considered. The small distribution is nothing but dm. What is the small distribution here? Dm is the small distribution. Are you getting? So in the place of mass, I am replacing that dm by, in the place of length, this dm mass distribution is considered along the dx length. This capital M is the mass distribution is taken along the length of the rod L. Total length of the rod is L. In the entire length of the rod, the mass distribution is nothing but capital M. In the small region of the length of the rod is dx. In this small region, what is the small amount of mass? Dm. That's why in the place of length, I am taking that dx. Dx. Getting? Now with that, I am taking the concept it as dm is equal to, how come I consider that? Dm is equal to cross multiplication lambda into dx. Just remember this. Dm is equal to, what's the formula now we got? Lambda into dx. Now along the x-axis, if the mass distribution is present, if you want to calculate the position of the center of mass with respect to x-axis, which formula need to consider? Which formula need to consider? Just now I said to you that xcm is equal to integral x into dm by integral dm. This only I said to you, right? So here I am taking this formula xcm is equal to integral x into dm by integral dm. Now that is equal to integral x dm. What is the dm? Dm is equal to what we got here? Lambda into dx. Substitute that. Lambda into dx by integral dm. Dm is nothing but, again, what's the value? Lambda into dx. So don't cancel here lambda dx like that is present. Don't cancel that. These are the mathematical derivations. This is one different part, and this is another different part. Don't cancel like that. Okay, now here that is equal to, see here now. Here I am taking further, that is xcm is equal to integral x into lambda. Lambda is nothing but what's the value? Given that a plus bx. Lambda is nothing but a plus bx. And again, what's the value? Dx is present here. As usually, write dx by integral. So lambda is nothing but, again, what's the value, ma? A plus bx into dx. Now xcm is equal to, so here a and b both are constants. A and b both are constants. Okay, so now at first you multiply every term. A into x dx, ax dx plus integral bx dx by a into dx. So integral a into dx, split the integration part, plus integral bx into dx. bx into dx. Now xcm is equal to a constant, take out, integral x into dx. Integral x into dx is nothing but x square by 2. X square by 2. How come we consider that? You know the formula. Integral x power n dx is equal to x power n dx is equal to, what's the formula, ma? X power n plus 1 by n plus 1. This is one formula. Integral here x into x power n dx is equal to x power n plus 1 by n plus 1. This is the formula. Okay, so now here in the place of n, what's the value? 1. So x power 1 plus 1 by 1 plus 1, that is x square by 2, plus b, and again here x into x square, no, sorry, x square. Now integral x square dx. Here already 2 is present. Now 2 plus 1, 3, x power 3 by 3, nothing but x cube by 3 by a. Integral dx is nothing but what? X plus b. Here x power 1 is present. So integral x power 1 dx, x square by 2. Like that. Now, where to where I need to consider? I need to take total length. The mass distribution is along entire length. Origin to this end. This is 0. Origin is nothing but 0. And this is nothing but L. Total length I used to take. So, here I am taking that the limits are 0 to L, 0 to L, 0 to L, and here also 0 to L. Are you getting? Now, if you substitute all these things, then you will get the value as, so upper limit L, in the place of x you substitute, minus lower limit 0 if you substitute, upper limit L and minus, and lower limit is 0, and then here upper limit L and lower limit is 0. So at the time of substitution of the lower limit, need to keep minus అనేది ఉంచాలి. Now here that value is, if you solve that, then you will get the value as 3al plus 3al plus 2bl square by 2bl square by al plus 3 into 2a plus bl. 3 into 2a plus bl. You will get this. Like that, we need to solve this type of concept. Now, this is the x-axis and it is the y-axis. This is the origin. And this is the projection which we considered, direction of the projection of a bomb. The bomb explodes. Now the bomb is projected in this direction. Actually, the bomb need to reach this point. The bomb need to reach this point. If the bomb explodes, explosion of the bomb takes place. Instead of reaching this point, the number of pieces of the particular bomb can reach to 2 different places. Here, some conditions can be applicable. Listen, for example, I consider that this is the bomb. This is the bomb. If the bomb is projected like this, after reaching the maximum height, this bomb divided into 2 pieces. For example, and those 2 pieces are like this. This is one piece and this is another piece. These are the 2 pieces. Okay, so this bomb divided into 2 pieces. But in the bomb, before explosion, in that bomb, wherever the center of mass is present, at that center of mass, whatever the particle is present, at the center of mass, whatever the particle is present, that particle follows the same path as earlier after explosion also. Are you getting? Before explosion, if the explosion doesn't take place, the bomb reach this place, reach this point. If the bomb doesn't explodes. Now, what we considered, now the bomb explodes into two pieces. Explodes into two pieces. So if the bomb explodes into two pieces, then here we are taking that, listen, two pieces, explodes into two pieces. Now those two pieces here I am mentioning that little bit bigger. Like this. One piece falls freely. So one piece takes thrust. Then another piece followed some other direction like this. But the particle which is present at the center of mass, that particle of the bomb travels the same path as earlier if the bomb doesn't explode. బాంబ్ ఎక్స్ప్లోజన్ జరగకపోతే ఏ డైరెక్షన్ లో అయితే ట్రావెల్ అవుతుందో ఆ బాంబ్, ఏ పాయింట్ దగ్గర అయితే స్ట్రైక్ అవుతుందో ఎక్స్ యాక్సిస్ మీద, అట్ ద సేమ్ పాయింట్ ఆఫ్టర్ ఎక్స్ప్లోజన్ ద పార్టికల్ విచ్ ఈస్ ప్రెసెంట్ అట్ ద సెంటర్ ఆఫ్ మాస్ కెన్ స్ట్రైక్ ద ఎక్స్ యాక్సిస్. ఆర్ యు గెటింగ్ ద పాయింట్? Now here, as you know that the projection point as well as landing point, generally we are taking the range of the projectile. Exactly, it falls at the center, highest point. From highest point it falls straightly and strikes the ground. So this distance is nothing but r by 2. Exactly middle, highest point exactly middle, r by 2. Okay, now the another thing is nothing but from origin. What is the question? From origin to the other part where strikes the ground, I need to calculate. This is the other part. Second part strikes the ground at this point. From the origin, this point is at x distance. We need to calculate x value. For that purpose, here we are taking that xcm is equal to, we are taking this formula, xcm is equal to m1x1 plus m2x2 by m1 plus m2. For example, initially the mass of the bomb is 2m. Initially, what's the value, ma? 2m. The mass of the bomb is 2m. Now it explodes into two equal pieces. This is m and this also m. Okay, now xcm is nothing but, what is the meaning of that? At the center of mass of the particle, at the center of mass of the bomb, whatever the particle is present, that follows this path and strikes the ground. And what is the xcm? Range, r, that never changes. So now here we are taking that r is equal to m1, that is nothing but capital M, 1 mass, and where it strikes from the ground. So from the origin it strikes at r by 2 distance plus m2, another mass, and capital M, that is okay. And again from the origin, this second part strikes the ground at x distance. So this is m2 x2. X2 is nothing but x. By total mass. M1 is m and m2 also m. M1 is m and m2 also m. And take out the m as common and cancel. Then you will get the value as, see here, ma, R is equal to, here take out the mass as common. Here 2m represents, get cancelled. Here what left? R by 2 plus x by, what's the remaining value? 2m, no. So m cancelled. Here we have only 2. Okay, now here I need to calculate what is the range. So I need to calculate that range of the projectile. So the range of the projectile, here I am taking that R is equal to, what's the formula, ma? U square sine 2 theta by g. For example, here this is 45 degree. So for 45 degree, the range is maximum. So here how come we consider that? R is equal to U square by G. Okay, so like that, here we consider. For example, if the problem is considered like that, in such a way that if the bomb initially projected with the velocity of 20 meter per second, then acceleration due to gravity is taken as g is equal to 10 meter per second square. Then R max, nothing but R is equal to 20 into 20 by 10. That is equal to, R is equal to 40 meters. So range is considered as 40 meters. If you substitute 40 meters here in the place of R 40, then you will get it as 2R cross multiplication, R by 2 plus x. Then x is equal to, if you consider, then that value is simple. X is equal to 2R minus R by 2. 2R. R is nothing but 40. 42s are 80. Minus R is 40. 40 by 2, 20. That is equal to, X is equal to, what's the distance? 60 meters from the origin. That's it. Two bodies of 6 kg and 4 kg masses. In this problem, M1 is equal to 6 kg and M2 is equal to 4 kg. M1 equal to 6 kg and M2 equal to 4 kg. Have their velocities. V1 is equal to, here that is given in the form of vector. So V1 bar is equal to 5i cap minus 2j cap plus 10k cap. And another velocity of the particle, V2 bar is equal to 10i cap minus 2j cap plus 5k cap. Find the velocity of center of mass. So here, which formula we need to consider? VCM bar is equal to, here vector representation we have, options also in vector representation. So VCM bar is equal to M1 V1 bar plus M2 V2 bar by M1 plus M2. So just substitute V1 value and V2 bar value in this problem and get the answer, VCM bar. Listen, ma. Here this topic is related to the removal of mass. Generally, removal of mass ani anagane need to remember one formula. What is that formula? Shift in the center of mass, delta x shift is equal to minus m removed into d by distance between the two center of masses m initial minus m removed. Need to remember this formula. ఈ ఫార్ములా నీకు ఇమ్మీడియట్ గా గుర్తుకు రావాలి. సో ఇప్పుడు ఏం చేస్తున్నారు అని అంటే ఇక్కడ దిస్ ఇస్ ద స్క్వేర్. ఓకే, సో ఈ స్క్వేర్ లో మనం తీసుకునేటువంటిది ఏంటనంటే దీని యొక్క లెంత్ ఎంత తీసుకుంటున్నాము అని అంటే 2l. Length is 2l, nothing but side. The side of the square is 2l. Okay, so now here we considered this is one and this is another. Like that, four equal parts we considered. In the four equal parts, in one part, 1/4 part of the square, in 1/4 part of the square, one circle is removed. One circular part is removed. సో ఈ ప్లేస్ లో ఉన్నటువంటి సబ్స్టెన్స్ అంతా ఏమైపోయింది, బయటకు వచ్చేసింది. సో బయటకు వచ్చేస్తే సెంటర్ ఆఫ్ మాస్ ఏమవుతుంది, స్క్వేర్ మాత్రమే అలానే ఉందనుకోండి, ఇక్కడ ఉంటుంది సెంటర్ ఆఫ్ మాస్. ఇప్పుడు ఈ స్క్వేర్ లోంచి సర్కిల్ రిమూవ్ చేశారు, కాబట్టి ఈ సెంటర్ ఆఫ్ మాస్ ఏమవుతుంది, ఇట్ కమ్స్ బ్యాక్వర్డ్స్, ఇలా వెనక్కి వచ్చేస్తుంది, ఇట్ మూవ్స్ బ్యాక్వర్డ్స్. So we need to calculate shift in the center of mass, that we need to consider. First, here m initial, m removed. I said to you very clearly that mass is directly proportional to area. Mass is directly proportional to area. Okay, so mass is directly proportional to area means at first I am taking m initial. M initial means what? Before removal of circle from the square, whatever the mass is present, and that is the m initial. Are you getting? Before removal of the circle, whatever the mass is present of the square, that is the m initial. So what is the area of this square? Side square. What is the side of that square? 2l. So that's why here I consider that 2l whole square. This is the m initial. What is the removed? M removed. Here the shape of the removal part is very important. Which one is removed from the square? A circular shape is removed. A circular shape is removed. So this is a circular part is removed. So circular part I am saying. So the removal part mass is directly proportional to area. What is the area of the circle? Pi r square. Pi r square. Here r is the radius of the circle. How come we calculate the radius of the circle? How come we consider the radius of the circle? Now, this is the center, first center of mass. This is O. Here I am taking the radius of the circle. For that purpose, here I am taking that. Listen carefully, ma. Total diagonal is considered initially. Total diagonal is considered. Total diagonal is nothing but, how come we represent that? How come we consider that? This is 2l, this is 2l, and this is 2l. This side is 2l. Total, I want the diagonal. Diagonal is nothing but, here I am taking x. Root over side square plus side square. 2l whole square plus 2l whole square. That is equal to root over 2 into 2l whole square. 2 into 2l whole square. And that is nothing but, and this 2l comes out, root 2 there only, 2 root 2l. That is diagonal. That is diagonal. In that I am taking half. I require this. So once again, here I am taking the concept it as Here, after calculating that distance between this is the initial and this is the removal part center of mass, O dash, removal part center of mass. This part I required, this part. This is the distance between both, distance between both. So how come we consider that? How come we consider? Listen carefully. This is exactly half, no? This is L. This is half. This is L and this is also L. At first I am taking this part. So O dash, that O dash itself is nothing but D, distance between the two center of masses. And this is L and this is L. And what about the diagonal? Diagonal is nothing but root 2L. The diagonal I am taking that root 2L. In the diagonal of this part, so ఇక్కడ నుంచి ఇక్కడికి ఉన్నటువంటి ఈ పార్ట్ లో నాకు కావాల్సింది హాఫ్ O dash. So now I am taking that root 2L. D is nothing but root 2L by 2. Root 2L by 2. Observe carefully. This is root 2L up to here. From this end to this end, root 2L. Why? Because this is L, half part, and this is again half part. So diagonal, if I want, by taking the Pythagoras theorem, then this is nothing but root 2L. In the diagonal, in this small part, again I am taking half. Why? Because O1 O dash, observe carefully, O1 O dash, exactly half of this diagonal. Half of this 1/4 part of the diagonal. And that's why by 2. That is nothing but what's the value? L by root 2. What's the value, ma? L by root 2. Okay, again, here I am taking I want to take the radius, R. R is equal to. So radius is equal to, how come we consider that? See, this is L, no? This is L. Exactly this half. This part is L. Exactly, this is nothing but what? L by 2. So radius is mentioned as L by 2. So here, in the place of radius, I am taking L by 2. Observe carefully. R is nothing but radius. Radius is nothing but, this is the half the length, L. ఈ సర్కిల్ లో నాకు ఇంతే కావాలి అంటే ఈ టోటల్ లెంత్ లో ఈ పార్ట్ ఎంత ఉందమ్మా, ఎగ్జాక్ట్ గా హాఫే కదా ఉండేది. సో కాబట్టి ఇక్కడ దీన్ని నేను L/2 గా తీసుకున్నాను. L/2 అంటే దిస్ ఇట్ సెల్ఫ్ ఇస్ ద రేడియస్ ఆఫ్ ద సర్కిల్ R. సో ఐ మెన్షన్ హియర్ R is equal to L/2. Then another one, this is L and this is L. I want to take O1 O dash, distance between the O1 O dash. This O1 O dash is nothing but small d. So I calculated this 1/4 of the part consisting the diagonal as root 2L. ఈ 1/4 part of the diagonal ఎంత పార్ట్ అయితే ఉందో ఇక్కడ అందులో హాఫ్ తీసుకోవాలి, ఎందుకంటే O dash అనేటువంటిది హాఫ్ కాబట్టి. సో root 2L by 2, that is equal to what's the value ma here? L by root 2. Substitute these two values in this equation. Now here proportional to pi, R is nothing but L by 2. L by 2 whole square is nothing but what's the value? L square by 4. L square by 4. Now these M initial and M removed and distance between the two center of masses small d, this itself is O dash, O dash. All these values substitute in this formula. M removed is nothing but what's the value? Pi L square by 4. And distance between the two center of masses, d is equal to what's the value ma? L by root 2 by M initial, what's the value ma? 2L whole square, nothing but 4L square, minus M removed is nothing but what's the value? Pi L square by 4. Pi L square by 4. If you calculate this, then that value became as, that value shift in the center of mass is pi L by root 2 into 16 minus pi. This is the shift in the center of mass. Depend on the length here immediately, like this problem is present, immediately you need to remember this formula, pi L by root 2 into 16 minus pi. Just 2L, in that half is L, so substitute that L value in that, then you will get the answer. This itself is the hint, pi L by root 2 into 16 minus pi.